All right. Good evening once again, ladies and gentlemen. So, in today's class, like I've already stated, we are going to look at the properties of water, of which in this class we'll just focus on the multiple choice on the properties of water. So, from the previous lesson, from our lecture class, we talked about so many properties of water, such as it having the high surface tension, high heat capacity, high heat of vaporization, its unique density, and many other properties. So from those properties, we are going to look at few properties using the MCQ questions. And like I have stated, in this revision class, I'll randomly be pointing at someone, and once I point at you, you have to make sure that you respond and give the correct answer. It might not be a correct answer, but a try is better than silence. So the first question is, identify the correct description of a hydrogen bond. Identify the correct description of a hydrogen bond. So in the previous lessons in our lecture class, we stated that the type of bond which exists in water, it is a polar covalent bond. I hope we can all remember that it is a polar covalent bond. The reason why it is a polar covalent bond is that there is a difference in terms of electronegativity between oxygen and hydrogen, okay, such that the electrons which are being shared, they are mostly being drawn towards the nucleus of oxygen. In short, they are more closer to the nucleus of oxygen as compared to the nucleus of hydrogen. So this polar covalent bond leads to the partial charges which you can observe. Like the oxygen will have a partial negative charge and the hydrogen will have a partial positive charge. So because of these partial charges, there is an electrostatic force which exists between these. And this electrostatic force, it is an interaction which is known as the hydrogen interaction. But we know that the hydrogen interaction is a very strong interaction, especially in water. As a result, it's referred to as a hydrogen bond and not a hydrogen interaction. So as I was explaining, I'm pretty sure you guys were checking up the options. So I'll randomly pick someone. So I'll start with Frederick. What's your answer on this question?
My answer is answer number 3, which says a bond between oxygen and hydrogen of different water molecules.
All right, okay, that's correct. So there is a common mistake between option 1 and option 3. So most of the people would go for option 1, but option 1 is wrong. The reason why it's wrong is because of the term which is saying same water molecule. So a hydrogen bond doesn't take place within the same water molecule. Instead, it's between two different water molecules. And this hydrogen bond, like I have already stated, it's a very strong bond. And this bond, for example, in a water molecule, like a single water molecule, is capable of making 4 hydrogen bonds with 4 different water molecules. Yeah. All right. For a bond between oxygen of water and nitrogen, this is totally wrong, because this oxygen in water will be partially negative and that nitrogen will be partially negative. of which we know that negative and negative, they can't attract each other. They'll do what? They'll repel. So this is 100% wrong, and it can't take place. So a bond between two hydrogen atoms, this is also wrong. A bond between two hydrogen atoms, like what this statement is saying is, let's say a bond is created between these two hydrogen atoms. So this bond cannot exist. This bond cannot exist. So that statement is 100% wrong, because this one is partially positive and that one is also partially positive. So the bond is not capable of taking place. Okay, let's move on and look at the next question. Choose the statement which is false about water. Choose the statement which is false about water. Okay, so we have different options here, but one thing that we need to understand is that this question is all about the properties of water and how you can quickly apply them. So I'll explain once one of us give it a try the correct answer. Okay, who can we go with? Twabona, what do you think is the correct answer there?
Number two.
Number 2.
Number 2, ice is solid because its water molecules are held by ionic bonding.
Exactly.
Can you let me go?
Yes, I can. So the first statement, okay, this first statement in this particular question is ice is solid because its water molecules are held rigidly by ionic bonds. So you need to understand that the bond which is existing, whether water is in solid form or in liquid form, there are only two bonds that you expect in water. The first bond is the polar covalent bond. Take that, very important. The first bond that you need to expect in water is the polar covalent bond. So this is the bond that cannot be broken. It's the bond that cannot be broken. And the other bond which you need to expect in water, it is the hydrogen bond, and this is the bond which is normally being broken. So the statement here is wrong in such a way that in water we do not expect a ionic bond. Remember, these ionic bonds, they can only exist in ionic compounds. They can only exist in ionic compound. Okay, example of ionic compound, we can talk about what? Sodium chloride. Okay, so basically when you analyze this question, you can just pick 2 as your answer, because it's the first statement. For 3, we had a mistake. Instead of typing 4 degrees Celsius, we had put 440. Then the other emphasis that I'm going to tell you, or the tip that I'm going to tell you, you see these options. Okay, you see these options which are correct. These options, they become questions on their own. They are questions on their own. So as you study biology, make sure that you also know the options. So make sure that you know the options. Okay, we can move and look at the next question. There is one important thing that I can explain here. Water has a high surface tension, so the high surface tension is just due to the what? Due to the hydrogen bond, due to the Hb, which is just the hydrogen bond. If you look at this spider, it's able to float on water because of the high surface tension. If you put a pin, you get a pin and put it on water, carefully put it on water, it's going to float. The reason why it's going to float, it's not because of magic, no, it's because of high surface tension. Okay, because of the high surface tension. So let's move on. Choose the property which makes water an effective solvent. Choose the property which makes water an effective solvent. So if you look at the term solvent, the term solvent is just a liquid, okay, a liquid in which a solute dissolve, a liquid in which a solute dissolve. So now, water is being considered as a universal solvent. Water is being considered as the universal solvent. This simply means that most of the molecules, they tend to dissolve in water, okay? And things that dissolve in water, like solids that dissolve in water, are said to be what? Hydrophilic. So the word hydrophilic, it's just a term which simply means that water loving, or something that can dissolve in water. So now, as knowing this is not enough, we need to have a reason. Why is it that most of the molecules are able to dissolve in what? In water. So if you look at the nature of water, like I've already given, water is said to have a what? A dipolar nature. So water has a dipolar nature. Okay, so a dipolar nature, in some texts it will just simply be the dipole moment. In some texts they will write it as a dipole moment. So a dipolar molecule, or a dipolar nature molecule, it is a molecule that is partially negative and partially what? Partially positive. As a result, it's able to interact with the hydrophilic molecule. And these hydrophilic molecules, they have to exist in two types. It's either they are ionic, okay? It's either they are ionic such that they can dissociate in water, or they are what? They are polar molecules. So it's either they are ionic or they are polar molecules. So the reason why these this type of molecules are the only type of molecule that can dissolve in water, the reason is because of these partial charges. Because of these partial charges. Okay, so from what I've explained, I'm sure one of you is capable of answering. So I'll go with Miriam. Miriam, what's your answer in this particular question?
My answer in this question, I will go for 3.
All right, 3, which is just a dipolar molecule. I think everything has been explained. Okay, let's move on and quickly look at the other part. Now, this question is saying adhesive forces lead to dash, which is the process through which water is absorbed into roots of plants. So one thing that we need to understand is that we have long trees. Okay, is it possible for me to draw a tree? I think I can draw. Now there is no tree for red type. Let me just change my color and look at how best I can draw. So there are trees. I think there are trees that are green in nature. So there are trees that are very long. There are trees that are very long. So let's say this is the tree, this is a tree, this is a tree. Yeah, this is a tree. So there are trees that are very long in such a way that for these trees it is so like impossible in a human eyes to even think or imagine that water can come all the way from the roots and go up to the what? To the leaves. Anyone can be surprised if you are to tell a baby and tell them that, no, you know, kid, water normally comes from the roots and go to the leaves. They'll surely tell you or ask you how and why. So two important forces help in this movement. Two important forces help in this movement. So you need to observe that water will start moving from this region going up, this region again going up, due to two forces. The first force, it is the adhesive force. So the adhesive force, it is the force which is between the walls of water and the walls of another object. In short, what you are saying that this force is between unlike molecules. The force is between unlike molecules. Then within the water molecules, they are able to interact with each other, causing the what? The cohesive force. Causing the cohesive force. So two forces. One, it is the force between the like molecules, like water and water each. Then they'll cause what? A cohesive force. And then adhesive force will be between water and the walls of the tree or the walls of the capillary. Like in this case, if this straw was to be put in this particular dish, you can observe down there the water will start climbing. Down there the water will start climbing. So the reason why water is climbing there, it's because of the two forces. One, the first force, which is between water molecules and itself, and then the other force is the one which happens between water molecules and the walls of the straw. Now, with that in mind, these two forces will lead to a property of water. These two forces will lead to a property of water which we are looking for in this particular question. So who can we pick? We can pick Loveness. What do you think is the answer on this particular question? I'm sure Loveness is around. What's your answer? Loveness, your network is bad. What's your answer on this particular question from the explanation that has been given? Nikarakuten mouse. Okay, I think maybe a network is bad. Ethel, what's your answer on this particular question from the explanation? Ethel? Please unmute yourself and then you can respond. Okay. Unmute yourself and respond. Oh, okay. Florence, what's your answer on this particular question?
The answer is capillary action.
All right, thank you. Okay, so we can move on and just pick capillary action, which is the correct answer. So the most important reason for the unique shape of water is dash. The most important reason for the unique shape of water is dash. So the first one is the covalent bonding pattern in water molecule. 2, the bond angle between the two hydrogen bonds. So remember, the bond angle is just between 104.5 degrees to 109.5 degrees. I think this is something that I am supposed to mention. Then the presence of a lone pair of electrons. So you need to understand that we have 4 electrons that are pending, and these 4 electrons are just the lone pairs of electrons, and these electrons are on oxygen. These electrons are normally on oxygen. So oxygen has 4 lone electrons, because pair means 2, so it has 4 electrons, 4 pending electrons. And then the other one, that water can be ionized at room temperature. Water can be ionized at room temperature. So according to all these options, I think I've skipped some because some will need more explanations from chemistry, like this one will need more explanation from chemistry. And then this one, it's the polar covalent bond. We know the type of bond, the bond pattern in water is just the polar covalent bond. Okay, so if you look at these options, can someone try to tell us the answer? Anyone to try? Oh, I'm supposed to point. Chimuka, what's your try? What's your try? Chimuka?
2, the bond angle between the two hydrogen atoms.
Okay, so you are right, but the thing is, my advice on this particular question is make sure that you go through all the options. So if you look at the first option, it's correct, because this polar covalent bond will lead to the HB bond, and this HB bond can also play a role in terms of the shape. So basically the correct answer there was 5. So 5 was the correct answer. Okay, so we move and look at the other question. When a lipid is mixed with water, the two immediately separate. So if you look at this cup this side, there is water here, there is water, which is H2O, and then there is cooking oil, which is the lipid. So the nature or the behavior of lipids is that the lipids have a what? Have a tail. So this is the tail, and the head. So the head, it's normally interact with water, and the tail doesn't interact with water. As a result, since lipids have 2 parts, the part which interact with water, so this part is known as the hydrophobic part, because it's the part which doesn't interact with water. And then the head is said to be what? It is said to be hydrophilic. So I'm going to explain more when we do lipids, when we do the topic lipids. So for this question, I'll surely answer it myself, but I'll explain more when we do the lipids. So here the answer is just amphipathic. Lipids are amphipathic. So when you talk of amphipathic in molecules, these are molecules that are capable of interacting with water, and also they cannot interact with water. That simply means that lipids do not dissolve in water. Do not dissolve in water. They do not dissolve in water, but they can interact. They can interact. They do not dissolve in water, but they can interact, such that the head is hydrophilic, it's water loving, and then the tail is hydrophobic, it doesn't like water. So this will be explained later on. Let's move on and look at the next question. So the next question is saying polar molecules can readily dissolve in water because, so all the concepts which are on this particular question, I think I have explained them all. So let's pick someone to give it a try. Owen, what's your pick? What's your answer on this particular question? Owen?
I go for 3.
You go for 3? Okay. So,
Yeah.
you are correct, but like I've already stated, make sure that you go through all the options. So if you look at 3 is correct. Water can interact with charged solute molecules. Yes, this is correct. Now, these charged solutes are just what? Polar molecules. Polar molecules are charged molecules, and yes, they do dissolve. Even ionic molecules, like I have already stated, the ionic compounds, they also dissolve in water. Both of them, they are what? They are charged. Now, there is also A or 1, which is saying polar molecules can form hydrogen bonds with the water, which is also what? This is also correct. So if you watch again the lecture class, you're going to understand that there is a part which I had to mention things like water, I had to mention things like carbohydrate. So during that part, that I was just trying to explain what a polar molecule is, and these polar molecules, they are normally hydrophilic, and the reason why they are hydrophilic is that they're able to form the hydrogen bonds. Example of polar molecule, you can pick things like glucose, you can pick things like glucose, you can pick something like proteins, okay, you can pick something like proteins. So that's it. So the answer here was just 5. Take note of the typing mistake. So the answer here was 5, which is option A or 1 and 3 are correct. Okay, in a water molecule, the non-bonding electron in oxygen are, I think this is something that I've already explained, so we can't waste much time on that. So we'll go with Taonga. What's your answer on this question?
It's 4.
4, correct. So the non-bonding electrons in this particular compound, which is water, you can talk of this is a non-bonding electron, that one is a non-bonding electron, that one is also a non-bonding electron, also that one is a non-bonding electron. So these are electrons that are for oxygen, and they are just 4 of them. 1, 2, 3, 4. So the answer is 4. Water is liquid at room temperature because of dash. Okay, water is liquid at room temperature because of dash. So I think this is something that has been explained already. So I don't know if we have someone who can answer, so we can go with Naftali. Your name is a bit hard. Naftali, what do you think is the correct answer?
Okay, I think it's 5. Option 5.
Okay, yeah, option 5 is correct, because when water is a liquid, it has a high chance of becoming a gas. So it also has a high chance of becoming a solid. So when you talk of the change from the liquid to a gas, that will need boiling, and that's evaporation. And during evaporation, you need to understand that the HB will be broken. Will be broken. Okay. And then the other thing that you need to understand, that for water to go from liquids to solids, that's known as melting. Is it melting? Melting is from solid to liquid, isn't it? Melting, is it solid to liquid or liquid to solid?
From solid to liquid. Solid to liquid.
Solid to liquid. Then this option is wrong. So in such a case, then we'll go with 1. We'll go with 1. The reason is that unless this was solidification or freezing, yeah, we can pick it as one of the options. But since melting is from solids to liquids, then surely we can't pick it up. So the option is just A, or 1, which is the high boiling point of water, which is just simply high. Okay, but remember this statement I've given this side, where the hydrogen bond will be broken, and during evaporation or boiling, this statement is an exam question on its own. Which word best describe the attraction of a molecule to water? I think this has already been explained, and we can just easily solve it, and I think I'll pick it up. So the answer is just hydrophilic. Hydrophilic simply means that it's water loving. Yeah, it's normally loves water. Okay. Don't know if I still have the skill of drawing a love water, love H2O. Yeah, it's normally love H2O. So when you talk of molecules that are capable of dissolving water, that means that they are water loving. So this is the only real love that exists on Earth. We move on. Choose the correct statement about the arrangement of water around ions of common salt. So if you look at salt, which is sodium chloride, so when this one dissociates, it will become sodium positive, and this one will become chloride positive. So also chloride negative. And then if you look at the nature of water is something that has a hydrogen and another hydrogen. So the hydrogen is partially positive, and the hydrogen again partially positive, and the oxygen will be partially negative. So in this case, what will happen is that this oxygen, which is partially negative, will go and interact with the one which is partially negative, and then this hydrogen, which is partially positive, will go and interact with the chloride, which is partially negative. But before these guys become partially negative, they are going to dissociate. Okay, they don't form hydrogen bond. Please get me right on this one. There is no hydrogen bonds between water and the water and the ions which come from the common salt. No hydrogen bond, because this is ionic and this guy is partially, in short, it's a dipolar molecule. So the interaction cannot be hydrogen. So it's just an electrostatic force between them. So if you look at these options, if you look at option 1, which we can set to be A, and then that one B, this one C, this one D, and this one E. So if you look at the option, this one is correct, like I've already stated. This one is also correct, and then this one is also correct. So the answer is simply 5. Ions of common salt floats on water. No, this is wrong, because they do not float on water. Instead, they'll simply just dissociate and dissolve in water. So the reason why ionic compound like sodium chloride, the reason why ionic compound like sodium chloride, the reason why they dissolve in water is because they dissociate. It's not they form hydrogen bond. I think I need to emphasize on that. It's not they form hydrogen bond, they dissociate. Okay, hydrogen bond, which is Hb, no, but T dissociates is what is expected to be given a reason when you are trying to explain the interaction. Do we have any question on this one? Do we have any question on this one before we move on? Okay, it's like we don't have any question. Then, water is a liquid at room temperature. Water is a liquid at room temperature. I think this has already been explained. The most important reason for the unusual behavior of water, whatever, has this been explained? Okay, I think this one hasn't been explained, isn't it? So the answer for this particular question, it is just the hydrogen bonding between its molecules. So the most important reason for the unusual properties of water is because of the hydrogen bonding between its molecules. We met a question somewhere where we talked about these same unusual properties, but for that question there was an option which had this guy here. So this guy is talking about the shape. Even that one plays a role in the shape. So this one and that one are correct when this part is talking about the shape, but this question is not talking about the shape, it's talking about the properties. As a result, the hydrogen bond is the correct answer. If you look at the hydrogen bond which is taking place there, there is a hydrogen bond which is taking place there. So that hydrogen bond, it's very hard to be broken, and it's a reason why there are so many properties of water that you can take note of. Okay, why do the atoms okay, yes.
Have we answered the previous question?
Yes, we have. It was answered.
Okay. Thank you, sir.
You're welcome, madam. We move. Why do the atoms of a water molecule attain partial charges? I think these are things that have already been explained, so we were just moving on the same thing, So once you understand everything, then it's more like everything will look like a repetition. So why do the atoms of a water molecule attain partial charges? So this is one because of the difference in electronegativity, okay, electronegativity, and then also an equal sharing of electron, and then you need to understand that this unequal sharing of electron is in such a way that the electrons are mostly put towards the nucleus of oxygen. So let me randomly pick someone who can quickly tell us what the answer is from there. Twabona.
Number 3, sir.
Number 3. So according to Twabona, the answer is simply 3. Okay. Now, is it raining at your place?
Yes, sir.
Oh,
It's raining and there's no power.
that's good.
Planes here, most of them, sir.
Okay, thank God. So, the partial charges which the molecule of water is just because there is an equal sharing of electrons between oxygen and hydrogen. I think this has been explained on that particular part. Ice is able to float on liquid water because, so you need to understand that this is the ice block here. This is the ice block, and then there is water down there. So if you look at the ice block, you need to understand what the formula density is, which is mass over volume. So the reason why this huge ice is floating on water, because it has small volume. It has small volume. Is it small volume or big volume? So for density to be small, then the volume has to be small. Yeah, the volume has to be big. So the volume has to be big, and then for the density to be big, then the volume has to be small. Yeah, because these guys are a little bit indirect proportion. So one thing we need to understand that for this to float, then that simply means that the density is small. Okay, the density is small. For this thing to be big, to float there, it's because the density is small. Then if the density is small, then the volume is big. The volume is big. Remember, the mass has to remain the same. It is constant. Okay, a mass is constant. If we borrow the knowledge from physics, it is a scalar quantity. Since it's a scalar quantity, it doesn't depend on the direction or in which form it is. It is just simply constant. So this is now the game of us understanding how these guys are. So the thing is, the density of a liquid water below this ice surface increases. So once the water molecules are becoming liquid, then the density normally increases. Okay, the density normally increases. So the reason why the density normally increases is due to the decrease in the decrease in the volume. So the decrease in the volume is the one that leads to this liquid water to be denser than the ice. Okay, so with that in mind, we can move on. Which of the following statement is not true about water? Which of the following statement is not true about water? So when water boils, covalent bonds are broken. Water molecule hydrophilic. A water molecule is not linear. Water is an excellent solvent for polar substances. Water has a high latent heat of vaporization. I'll pick Taonga. What's your answer on this particular question? Taonga?
When water boils, covalent bonds are broken.
Okay, so basically, like I've already explained, it's the hydrogen bonds which are broken and not the covalent bonds. So the answer here, well, the option which was not true or the option which was false is just one. Choose the statement which distinguishes liquid water from ice. So the first option is, in liquid water, each molecule is surrounded by 4 other water molecules. So yeah, this is true, but it's not differentiating this one from that one. In liquid water, molecules are more densely packed. So density is equal to mass over volume. Mass over volume. So if they are densely packed, that simply means that the volume has been what? The volume has been decreased. The volume has been decreased. So when the volume has been decreased, simply means that the density will increase. So that will be our answer in that particular question. That's why liquid water is denser than ice. Liquid water is denser than ice. The reason why it's denser than ice is because of the differences in terms of their volume. Capillarity of water in a vessel depends on, for this one, I'll quickly solve it. So this one is our A, this one is our B, this one is our C, this one D, and then this one our E. So I think this one I explained it already, so the answer is just A and C. I think this one we already did it, so that's the answer. Do we have any questions on this particular part? Okay, we move the meniscus of water in a narrow tube. The meniscus of water in a narrow tube. So if you have a tube there, you need to expect the behavior in terms of the meniscus of water. So for water, it curves downwards. For water, it curves downwards. So the meniscus of water, it's normally curves downwards. Unlike in mercury it curves upwards, but for water it curves downwards. The reason why this is happening is because the cohesion forces are greater than the adhesion forces. So there is air. There is air. So air is interacting with the water molecules on top, and the interaction is the adhesive forces. Then water within itself is interacting with itself, and those are what? Cohesive forces. So the cohesive forces are stronger than the adhesive forces. As a result, the answer here, this one, no. If you look that one, no. If you look at this one, it's correct, which is correct. The rest are not correct. That one, not correct. This one, it's not correct because of the adhesive forces. Water molecules are Quite alright, they form the adhesive forces with the tubes of the hole, but they are not a reason why this guy is curved downwards. Okay, we can move. Which of the following statements describe a covalent bond between carbon and oxygen? So even this one I'll solve it myself because of time. So carbon and oxygen, these two guys, you need to understand that this one has low electronegativity, as compared to that one. So oxygen has a high electronegativity. The same behavior that happens in water and in oxygen and hydrogen, it's the same behavior, just that this bond